Hey there, School of Tomorrow students, Pythonistas, design scientists. The star of the show is again Codesters today, but we're linking up to this topic of phasors, which we can credit to Steinmetz. So I've been reading that history of vector calculus, which I believe is cited in this paper, Steinmetz and the Concept of Phasor, A Forgotten Story. So this is translated into English, I believe, and it's an interesting article that I recommend. So I'm then linking to Martian math cartoons. So you'll remember that Steinmetz, you may not remember, but he's known as someone really good at grid computations. Like he understood about AC current and all the weird things that could happen, like when you try to shut it down wrong, or all the things that the pathologies of AC were really stumping people at the dawn of the electrical age, right? Tesla's belief that AC would win out as the primary distribution strategy that panned out, but still it had its mysteries as to how to do computations around AC, right? And complex numbers came into it. And we have a lot of thinkers going in that direction, right? We have Hamilton, we have quaternions. It's like all this math is coming into being, you could say, as we're diving into this phenomenon and kind of need a math that does this. It turns out complex numbers save our bacon, you could say. Now in Codesters, I've gotten more fancy, or fancier, as you could say, where I'm creating multiple turtles as before. I've called one voltage another current to kind of give the idea that we're entering the space of electrical theory. And I didn't bother to even give names to T and S other than T and S. And then we go into this grand loop, which basically is multiplying, or raising, I'm sorry, it's raising math.e, Euler's number, to a complex power, right? We were doing that in the spiral examples a couple videos back. And all we're doing here is elaborating on that a little bit, showing how you can introduce a phase shift, you can play with the frequency, you can play with the amplitude. I noticed this version doesn't play with the amplitude anywhere. So let's see, I would like to play with the amplitude and do a 1.5 times in front, and that's going to give us, one of the turtles is going to make wider wags. So frequency, right, it's how much the turtle goes up and down, how frequently. And if you have a high frequency, you know, you have to change direction a lot more often. That's a lot more work. If you're like wiggling a rope, if you wiggle it really fast, that's going to burn calories faster. You're actually spending more energy for the high frequency. But then amplitude also takes energy, right? If you just boost the sound, it's not a frequency thing, it's just an amplitude thing. So this looks like they're almost on the same frequency. Why? Did I not mess with the frequency? Right. Frequency is pretty much the same for both, just there's an offset. So let me run it again. This time I'm going to mess with the frequency a little bit. I'm going to take the Z ones, and instead of dividing by 10, I'm going to divide by 8. So I'm getting a bigger number because I'm dividing by something smaller, and so I'm going to get a higher frequency. So this is the kind of thing you can learn from all kinds of great YouTube channels. I'm just sort of skating along this ice here, showing you the way that we can use Codesters to play with Euler's formula for wrapping basically around a unit circle. That's what E2 in a complex power is able to do, is go around a circle. But then the question is, what is the radius of that circle and what is the speed at which we're going around it? And then we plot the x or y axis position, as a function of time, because going around and around is taking time. So circles can spin faster or slower, they can be bigger or smaller. That's the kind of thing we're playing with and graphing here. So you can see that the purple turtle, 1, 2, 3, 4, 5, it got more bumps in. It's the cyan turtle. Oh, I see. Yeah, they come in pairs, don't they? Because I'm springing 2 turtles off each of the 2 circlers. Z and W are kind of going around in a circle, and then I'm taking reads off of those to get my waves, my sine and real and imaginary parts both get graphed, okay, of each of these. So that's 4 in all. Anyway, the kind of game you might want to play, and then link it to all this stuff about the grid, and you get the idea of where people are going with this math, because we're trying to get both Martian math and Earthling math in the picture so that we can build these hydropower dams, right, with some Martian influence. And what that looks like might be involving how we depict energy amounts in terms of growing and shrinking tetrahedrons and stuff. You can also get some of your trig from those same color plates I was talking about. If you want to look at this poster, I won't go through it in any detail, but trig is everywhere. Trig is a beautiful thing, especially linked in with the complex numbers. So enjoy, and we'll see you soon.